Welcome viewers. Today we are going to start with exercise 7.2 of class 8 mathematics, cubes and cube roots. Question number 1. Find cube root of each of the following numbers by prime factorization method. So these numbers are perfect cube. 64 is also divisible by 2, hence it has to be divisible by 8, the cube of 2. So let's straight away start with 8. If we divide with 8, we'll get 8 8s are 64. Again, we'll divide with 8 and we finish this just in 2 steps. Now we can write 8 as, we got 8 into 8, so this 8 can be written as 2 into 2 into 2, and this 8 can be written as 2 into 2 into 2. We have got the all prime factors. So this is 2 cube and this is 2 cube, and this is equal to 2 into 2 cube, that is equal to 4 cube. So 64 is equal to 4 cube. Inverse operation, cube root of 64 is equal to 4. Clear? Again, this number is divisible by 2. So we'll again take 8 straight away. So we'll get 8, again 8, again 8. So we'll again write this 8s, we'll get as 8 into 8 into 8. Okay, that means 2 cube into 2 cube into 2 cube, that is 2 into 2 into 2. 4 into 2, 8 cube. So we have got it here as 512 is equal to 8 cube. So cube root of 512 is equal to 8. Clear? This number again is divisible by 2. We'll start with 8 again. 1, 3, 3, 1. Now 1 3 3 1 is not divisible because ending with 1, so we cannot take 1 and 9 we cannot take, so we'll go to 11. So 11 1 20 1. Now we have got 11 square 1 to 1, so 11 11 1. So we get the prime factors as 8 is equal to 2 cube and this as 11 cube, and you can write this prime factor in expanded manner while solving an exam. So we'll get 2 into 11, that is 22 cube. So we have got cube root of 10648 is equal to 22. Here we'll straight away divide by 10, so we'll have here 27 0 0, again divide by 10, we'll have 27 0, we'll divide by 10, we'll have 27. Now we'll divide by 3, we'll get 9, 3 again, we'll get 3, 3 again, we'll get 1. Now we can write 10 as 5 into 2, so I got 3 tens, so this will be the factor. So again I'm repeating, during exam you have to expand it and write, otherwise the concept of prime factorization will go wrong. So this 3 cube, so we have got 5 into 2 10 into 3 30 cube. So cube root of 27000 is equal to, inverse operation, we get 30. Clear? So this number is divisible by 5. 125 is 5 cube. So we have got the prime factors in all 5. So we can write this as 5 cube into 5 cube. So we have got 5 into 5, 25 cube. So cube root of 15625 is equal to 25. Clear? So again, we start with 8 because this number is divisible by 2. We have 8 again. We'll take 2 the 16. Not 1, not 2, 4, 6. 216. 216 is cube of 6, so we'll take 6 and we'll have here 3, 6, again 6, we'll take here 6 and we'll have 1. Now we have taken, none of these are prime numbers, so while writing on steps you should expand and write. So 8 can be written as 2 cube. This 8 can be written as 2 cube. This 6 can be written as 2 into 3. So 2 cube into 2 into 3 cube 6. So that makes us get this 2 into 2 into 2 into 3 cube. So I got 24. 4 into 2, 8. 8 3s are 24. So I got 24 cube. So cube root of 13824 is equal to 24. Clear? Divisible by 2. Again we'll start dividing with 8. 1. So again we'll divide with 8. Again we'll divide with 8. Divisible by 2 again. 1. Sorry. 216. We just solve. 216. We get 36 here. Again with 6. 6 and so now we'll expand and write 8 can be written as 2 into 2 into 2, 2 cube. This 8 can be written as 2 into 2 into 2, 2 cube. Again 2 cube. Again into 2 cube into 3 cube. This is 6. Clear? So we have got 2 into 2, 4. 4 2s are 8. 8 6 are 48. So we got 48 cube. So cube root of 110592 is equal to 48. Clear? Again, let's start with 8. Fives are 46. 6. We have got 66. Again, we'll divide with 8. 729. 729 is actually cube of 9. But we can go slow or we'll take 9 here. So we'll give 1. Again 9. We have 9. Again 9. We'll have here 1. So again not prime factors. So we'll write this 8 as 2 cube, this 8 as 2 cube, this 9 as 9 cube. Okay, and 9 cube will be expanded, this 9 cube will be expanded to 3 into 3. So now we have got all the prime factors and we'll get result as 2 into 2, 4 into 3, 12 into 3, 36 cube. Hence, cube root of 46656 will be equal to 36. Clear? This number is again divisible by 2, so we'll take 8. Again we'll take 8. Again we'll take 8. Three 43 is cube of 7, so we'll take 7. So we have got the prime factors as 8 is 2 cube into this 8, 2 cube, this 8, 2 cube, and this 3, 7 is 7 cube. Hence, cube root of 175,616 is equal to 2 into, so we have 2 into 2, 4 into 2, 8, 8 sevens are 56. Divisible by 5. Again by 5. Again by 5. $729. This is cube of 9, so we'll take 9. Five is prime number, 9 is not, so let's further factorize it. So we can write this as 5 cube into 3 into 3 cube, which is a 9. So we get this number 91125 is equal to, this is 5 9s are 45 cube, inverse operation. So we get the result as cube root of 91125 is equal to 45. Clear? Moving on to question number 2. State true or false. Number 1. Cube of any odd number is even. So take any odd number, 3 cube is 27. It's not even. This statement is false. A perfect cube does not end with 2 zeros. Number ending with 2 0, let's take 100. And this is not a perfect cube. Minimum number of zeros we require is 3. So because cube of 10 is equal to 1000, 3 zeros. So this statement is true. If a square of a number ends with 5, then its cube ends with 25. A square of a number, let's take say 25. So square of this number 25 is equal to 625. This number ends with 5, but if we multiply again with 25, we get 5 here, and we need not to multiply, we can multiply and check, but this might take more time. But as a principle, you must remember, here we are going to get cross when you multiply with 5 and then 2. So we cannot comment upon the tens digit number in any case. Okay, so this statement is false. Fourth one. There is no perfect cube which ends with 8. Let's check. So if we take 2 perfect cube of 2 is 8. This number is a single digit number. So let's take another number say 12, which ends with 2. So that in unit position, we expect that it has to be 8. Okay, so we take cube of 12. So we get 12 into 12, 144. If we multiply again with 2, we get 8. 2. 5. So 1728 is the answer. So this number ends with 8. So the statement that there is no perfect cube which ends with 8 is false. The cube of 2-digit number may be a 3-digit number. So we know largest single digit number is 9. Cube of 9 is 729. It's a 3-digit number. 2-digit number, smallest one is 10. Cube of 10 is equal to 1000. So we are getting 4 digits. So there is no possibility that cube of a 2-digit number is a 3-digit number, because this is the minimum, and I have seen that cube of the smallest 2-digit number is 1000, which has got 4 digits. So this statement is false. 6-1. Cube of 2-digit number may have 7 or more digits. Again, we'll apply the principle. So 2-digit number. So we have seen that cube of a 2-digit number is 4-digit number. Now in this case, let's take the smallest 3-digit number. This is updated. Cube of 100 will be 1, then 2 zeros, 2 zeros, and 2 zeros. Okay. So cube of a smallest 3-digit number is a 7-digit number. Okay. So it is not possible that if we can take 99, its cube is definitely going to be smaller than this, and this is the smallest possible 7-digit number, and it is going to be a 6-digit number. Clear? So this statement that cube of 2-digit number may have 7 digits or more is again false. Cube of a single digit number may have a single digit number. So there are so many examples. We take 2, cube of 2, 8, cube of 1 is 1. If we take 3 cube, that is 27, it becomes 2 digits. So we have got evidence that there are 2 digits, single digit number whose cube is again single digit. So this statement is true. Clear? Question number 3. You are told that 1331 is a perfect cube. Can you guess without factorization what is its cube root? So we got a number 1331 and we have to find cube root of this number without prime factorization method. So there is a way. You take 3 digits from right hand side and form a group, and again you go towards left, form a group up to 3 digits. In this case we are left out with 1. We'll first deal this number. This number ends with 1. So cube of 1 is equal to 1. So there is only one possibility. So we'll have unit position of cube root of this number as 1. Clear? We have received the unit position or right hand component of cube root of this number. Now again we are left out with only 1. We have to find a cube which is either equal to 1 or less than 1. Cube of 1 is 1. So there is only one possibility, 1 is equal to 1. So we get the result as cube root of 1331 is equal to 11. Clear? Similarly, guess the cube roots of 4913. So 4913, we apply the same method. We group in, we take the 3 digits from right hand side. Now a cube of a number should end with 3. So we know 7 cube is equal to 343. So we'll write 7 here. And we are left out with 4. Cube of 1, 1. Cube of 2 is 8. So we have to take 1. And we get the result. So we write this as cube root of 4913 is equal to 17. Next one. We'll take 1 2167. Now, form a group. On the right hand side, we take the 3 digits. Now we have to see cube of which number ends with 7. 3 cube is 27. So write 3 here. Now we'll have to 12. 1 cube is 1. 2 cube is 8. 3 cube is 27, more than 12. So we'll take 2 cube as it, and we'll get the answer as cube root of this number is equal to 23. Clear? Now we have this number 32768. Again, you consider these 3 digits. We have to look for the number whose cube ends with 8. So I've got 2. Know the number in less than 10 ends with 8. So we'll take 2 here. Cube of 2 is 8. Left to 32. So we'll take here 3, because cube of 3 is 27, less than 32. So we get the result as cube root of 32768 is equal to 32. Clear? Most important thing you must remember. By this methodology, we can find cube root of a number up to 6 digits. Beyond that, this principle will not hold true. Clear? One advice, you must remember cube of number 1 to 10. That will help you in making the calculation fast, as you have seen. Clear?